Class is now starting. All attendees are in listen-only mode.
Good evening, and thank you for joining us. I'd like to welcome you to tonight's program, the Implant Single Unit, Understanding Today's Options, presented by Dr. Lou Graham and sponsored by DocStaff. Dr. Graham receives an honorarium for DocStaff for his time involved in preparing and delivering this presentation. Dr. Graham will speak for about 45 minutes tonight, followed by a Q&A session. You can type any questions you have for him or for myself, the webinar moderator, in the questions box in the control panel if you're on your computer, or if you're on a cell phone, you can click the question mark on the screen. This program is eligible for 1 CE credit, and those instructions for getting your certificate will be emailed to everyone tonight after the program has ended. This webinar is being recorded, and the replay will be available on the Catapult Education website later this week. I will now turn over to Dr. Graham. Have a great week.
Thank you, Lisa. Good evening, everybody, wherever you all are. I, like you, had our typical work day today, so I hope I can make tonight's program enjoyable and informative. All about the single implant crown. What are the options today? You know, here's the real world. This is a case I inserted last week, digitally scanned, and you're just not going to get implants always placed in the perfect position. It's just the way it is. I'd love to say that's not the reality, but this is the reality. So when I'm looking at milled abutments, 3D models, and I'm going to have to go with cement approach based on where these implants were positioned from the surgeon. Just another view of the model. And really, the whole idea of this lead-in is that not everything is ideal. And how do we accommodate? So the question really tonight is, do we screw implants in versus cementing implants? And I really want to tackle the literature a little bit, and then we'll get into 3 cases tonight and then questions. So the first question I bring up is cement versus screw, and it relates to a marginal bone loss issue. And what does the literature really say? Is one better than the other? So this was from Lemos and Souza. This was 2016, so a relatively recent systematic review of 20 studies, over 2,000 participants, almost 9,000 implants, with a follow-up mean of 65 months. And so the question, screw versus implant. No consensus had been reached on which retention system, cement or screw retained, is best to avoid bone loss around the implant of a fixed implant-supported restoration. No consensus. Mean marginal bone loss in this study showed, they said, statistically significant differences in favor of cement-retained prostheses, yet the overall conclusion of the study stated that the small differences in the mean values may not show clinical significance. God, I love these studies. The same study noted there are more prosthetic complications there are more screw-retained complications regarding the prosthesis. Yet, when you go back and look in Wilson's classic study, almost 10 years ago in 2009, he presented the relationship between the presence of residual cement in soft tissues and peri-implantitis development. So this was in JPD back then. And basically, excess dental cement was associated with the signs of peri-implant disease in the majority, 81% of the cases. Clinical and endoscopic signs of peri-implant disease were absent in 74% of those same implants after the removal of the cement. So cement's was and is still a huge problem. Yet, in comparison to screw, fewer prosthetic problems. It's really interesting. Then the question, if you have excess cement was left in the tissue, did it matter what type of cement it was? Are they all detrimental? So Burbano and again Wilson did further studies, and there are many, many different studies. And it really gets into the characterization of what type of cement particles were found in peri-implantitis affected via human biopsy specimens. So the particles that were found in these biopsies were associated with 5 commercially available dental cements. The particles in each biopsy could be associated with one of the commercial cements with a level of probability per them of 0.79 to 1. So what were these particles and cement? So tampon particles were found in 1 biopsy. Another cement called Telio particles were found in 7. Premier implant cement was found in 4. Rely X particles in 4, and IRM in 3. So again, these are inflamed areas, peri-implantitis, cements found. So then the question really is in tonight's lecture, which cements are we talking about that will be really the best in a cement-only situation? So this is probably the classic study. It was done at the University of Texas by Marvin and Galeos. And it was an in vitro evaluation of cell compatibility of dental cements used with titanium implant components. And what they really were studying was undetected residual cement left in the soft tissue. And what they were trying to figure out is, or evaluate is, what did the inflammatory process, what was it triggering? And what was leading to the loss of alveolar bone? So what the study was really evaluating was cement biocompatibility, and that it is a critical factor for implant cement. Not necessarily retention, but biocompatibility. So they evaluated 5 different types of cement. A nanostructurally integrated bioceramic, which is Ceramer. They evaluated a resin cement, a resin-modified glass ionomer cement, a zinc oxide eugenol cement, and zinc phosphate. So all 5 of these were tested for their cytotoxicity, not retention, their cytotoxicity. And the results, only the NIB, which was Ceramer, and zinc phosphate cement cemented on commercially pure titanium specimens demonstrated cell viability percentages above the minimum biocompatibility requirement. And this is huge because only these 2 cements were termed biocompatible. The other formulations, the resin, RMGI, and ZOE, exhibited moderate to severe cytotoxic effects on both cell lines in direct contact. And when they were cemented on these, CPTI surfaces. So their overall conclusion was the cement composition played a significant role in maintaining host cell compatibility. Additionally, it was observed pre-osteoblastic cells were more sensitive than HGF cells to cement composition. HGF or fibroblasts. Result of the work continues to illustrate the impact of cement formulations on host cell health and emphasizes the need again to understand the material properties when you're selecting formulations of dental cements. So am I picky on this? You bet I am. So for the last number of years, when I'm only doing a cement down, I'm going to show you 3 different ways. I've been using Ceramer. We'll get more into the technique itself because it's not just the cement. There's a wonderful technique that I'm going to demonstrate tonight. So let's talk cemented implants. The positives with cement, you have no screw access hole. That's a positive. Routinely, they're lower in cost. This accounts for the lack of proper emergence when the implant is placed in a non-ideal situation. And this can then accommodate non-ideal implants. Routinely, they're an easier delivery, but I always say maybe. There's greater resistance to porcelain or ceramic fractures because often, based on a screw access hole, the porcelain or ceramic may be thin in an area, and that may cause fracturing long term. Again, prosthetic failures were higher in screw-retained restorations. But there are negatives with cement. What about retrievability? When you need to retrieve it, we're talking tooth movement. When, per Tarnow studies, you put an implant on number lower right, lower left, and number 19 area, that's cement retained, you can pretty much assume those bicuspids and canines and incisors, they're going to move forward, and you're going to have an open contact. So that's a negative. Excess cement issues leading to periimplantitis is a huge negative based on Wilson and many studies. And then you get to the potential lack of retention and constant recements. I'm blown away by how many recements I am doing on implants placed 10 years ago by other dentists. I mean, the smallest abutments. And then you deal with stock abutments, which so many people still use, which I don't understand, versus custom abutments. So let's talk about how to make these cleansable at cementation. The first question is stock versus custom. This is from a lab that works with a surgeon. So here's a stock abutment, 4 millimeters below the gingival margin, and the surgeon placed the implant and the stock abutment. Now, I mean, when you look at this, forget the non-ideal margins of getting out the cement. What kind of retention are you going to have?